Good morning, students. In this class, we will study about the maxima and minima of a function. Here, we use the concept of derivatives of functions to find the maximum and minimum value of the various functions. Here, first we know about what is maximum value, what is minimum value. In a function, we take the graph of the function. It's the curve line or this line. There is it is an interval AB. It's an I interval. There is a point C. There is a point C. It's C. The f of C is having the maximum value. It's the f of C. It's the maximum value. This is the point is called maximum value. Here, another point in this graph is C in the interval AB or I. There is a point C in which f of C is minimum. Therefore, this point is called minimum value. First, we know about the definition of maximum or minimum value or maxima and minimum. Let f be a function. Let f be a function well defined. This function defined on an interval I. Then A. Here f of C is greater than f of x for all x in I. Here C is any point between in the interval I. Here C is a point in interval belongs to interval I such that f of C is greater than f of x for all x in I. Then B. Here also C is a point in I such that f of C is less than f of x for all x in I. And here f is said to have maximum value. Here f is said to have maximum value of f in I, and C is called point of maximum value. Here, let f be a function defined on an interval I. C, there is a point C in I such that f of c is greater than f of x for all x in I, then f is said to have a maximum value of f in I. C is called point of maximum value. Here f of c is less than f of x for all x in I, then f is said to have minimum value. Minimum value of f in I. Then C is called point of minimum value. Minimum value of f in I. Then C, here f of c is said to have extreme value if there exists a c in such that either maximum is f is either maximum value or a minimum value. It's called extreme value. If there exists a c such that f of c is either maximum value or minimum value of f in I, then c is called the point of extreme value. Point of extreme value. Here you have to note it here. F of c is greater than f of x in I, then f is said to have maximum value. Maximum value. And f in I, c is called the point of maximum value. If f is said to have minimum value of f in I, here f of c is less than f of x in I. Now we know about the graph of these functions here. Sometimes extreme points are here. It's extreme. A, B, x equal to A, x equal to B. Here, the point is C. Where is C? It's f of C. C, it's f of C. Here, f is maximum at x equal to C. Here, f is minimum at x equal to C. Here, f is having extreme points at x equal to A and x equal to B. Here, in the first graph, we see the maximum point. Only maximum in this curve. Here, it's only minimum. But in this third one, here maximum value is there and minimum value is also there. Therefore, f is have extreme points. Here, at x equal to A and x equal to B. X equal to A, f of A is minimum value. Here, f of B is maximum value. Therefore, we call it as extreme value. It's an extreme value. If only one maximum value or only one minimum value, we call it's the maximum of f function f. It's the minimum of the function f, and it's the c is called the point of minimum, or here c is the point of maximum. Now to solve some problems. Find the maximum and minimum values if any of the function f given by f of x equal to x square, x is belongs to R. Here you already know about the graph of f of x equal to x square. It's a parabola. Y is equal to x square. It's a 0. Here the function curve of the or graph of the function is here at 0, x equal to 0. The curve is having the minimum value. But here we can't say about maximum value because the interval is not given here. Therefore, from the graph of the function, f of x equal to 0 at x equal to 0. Also, f of x is greater than or equal to 0. F of x is greater than or equal to 0 for all x. X belongs to R. Therefore, minimum value of f is 0. 0. F has no maximum value. And hence no point of maximum value. Here point of minimum value is x equal to 0. Is the point of minimum value. Here we have to find draw the graph of the function f of x equal to x square. It's the parabola. Here the point of minimum is at x equal to 0. Its value is 0. In all other case, f of x is greater than 0. Therefore, the point of minima is 0. The point of minima is x equal to 0, and minimum value of f is it's also 0. F has no maximum value because the graph is continuous. F of x is x square. Here given is f of x equal to x. X is belongs to R. We can take x value or real numbers, but we restrict the domain of function to -2 plus 1. -2 plus 1. Then -2 whole square. F of x square is equal to 4. If it is -2, it's 2. It's 4. It's the 4. The graph of the function is 4. Then 1 square, it's equal to 1. X2 is 1. It's 1. The graph of the function is this type only. If we restrict the domain, x is belongs to -2 to 1, then from the graph of the function x is equal to, at x equal to 0 is the minimum, and maximum also here, which is at x equal to -2. at x equal to minus 2 is the point of maximum. Then f of minus 2 is equal to 4. 2 square is 4. Then the maximum value is maximum value if it is not given here. If they give the interval which is minus 2 to 1, the domain of the